say GA, release dates, that is still unclear. And yet this is something that we're showcasing that can give you a very good indication of how HP is intending to expose that technology and those capabilities in the future. So first of all, about predicting the future, right? This is something that is the holy grail of everything, right? Especially for business use cases and objectives. So predictive analytics is something that is highly valuable and highly rated. And everybody would like to get that in order to get a better insight of how they will come up with their objectives in the future. Any manager would like to get an introspection into what will happen in the future. So in order to achieve that, there is a vast amount of information, vast amount of data. We're all talking about this, right? Big data is the buzzword, is the situation that we're all dealing with in enterprises. And we all like to harness that for multiple objectives, let alone predictive analytics. And I'm going to talk about it today, how we can achieve that relying on your data. So naturally, when trying to achieve that, there are multiple challenges that are met, okay, in regards to skill set, resources, projects, people, all that, and more. And then I'm going to talk a little bit about what I call the magic behind the magic ball, okay, the crystal ball. What are those best practices, those common best practices that are employed by data scientists, by business analysts in the process of analyzing the data and creating these predictive models, this predictive analytics solution. And then I'm going to show you how what I call the guided approach towards predictive analytics that is part of the Workbench that we're introducing. So, first of all, a little bit about predicting the future, right? Everyone wants to do this for all the right reasons. Think about this VP sales that is dealing with all these disruptions, all those customers that he wants to satisfy their needs and sell to them, right? He has all those leads, all those opportunities that are in the funnel, and he's working really hard to achieve execution with those. So those are only a bunch of those questions that come up in a VP sales mind, right? How will I make up my projections, right? The revenue projections. How will I deal with customer attrition? I would like to be proactive about that. I would like to know if I have any customers at risk of attrition and maybe do something to change that really, really fast. In addition to that, how would I direct my sales operatives better? Okay, where to invest those? I have a lot of opportunities, hopefully. I have many resources that can direct better, okay, in order to close deal and close the quarter better, okay? I wouldn't want to invest efforts on opportunities that are most likely to be lost, for example. In addition to that, how can I increase the chances of closing a deal, right? What should I change? Should I reduce the pricing? Should I add more services? Okay, all of those are questions that VP sales is highly involved in. So what should you do? I mean, you have the more pragmatic and the less pragmatic methods to employ. Fortune tellers rely on hunch. I mean, I have a lot of experience as a VP sales or sales manager. Should I rely on my past experience only? Okay, or could I get any additional indication out of my big data on what would be predicted to be won or lost? What should I do? So this is another thing that I've found on the internet, right? I personally, as a dev manager, I'm always dealing with whether I'm going to make up my objectives, right? How is the project going? Will I make it in time for my release? Okay, this is another type of question, that another business case that is that can benefit from predictive analytics, for example. So let's talk a little bit about data, okay, and how predictive analytics is produced. In general, what happens is that, well, you can take some business analysts and have them make some reports and try to use your own past experience and maybe project from that onwards. But there is an alternative. Okay, you can use your own big data. You can start employing methods like data science that rely on machine learning algorithms, statistical models, and all that. And those can be actually employed on your data in order to realize what are the patterns that lie in there. Okay, and analyzing that, taking those patterns and projecting them on the future, on opportunities that are not yet determined whether we're going to be lost or won. Okay, and by that, get some sense of predictive analytics. While doing that, naturally there are some challenges to deal with. Let's talk just about several of them. One is you need the people which are involved with data and data scientists on board. Okay, so first of all, we all know a business analyst is sort of a master of the business problem domain, right? He knows the data, he knows the data sources, he knows really well about the situation in the enterprise. But when dealing with predictive analytics, then you start dealing with statistics, mathematical models, and all that, machine learning. So that compliance is relies at the area of the data scientist skill set. Okay, so then you need to look at a data scientist, better, a really proficient one, right? Someone that knows really well how to employ statistical models and machine learning, right? And have them work together, understand the same business problem. Another thing, once you have all that together, then you need to start gathering sufficient and reliable data. Okay, data that actually has the organization situation that is relevant for your business problem. Another thing is, how do you create the predictor? Okay, you have the business analyst, and he has to start using tools, statistical models, and all that. They're usually quite specific for the purpose, right? You have multiple tools like that, but then how do you find the right people to know how to use those tools and bring that into your enterprise? Another thing, how do you take the artifact that such a data scientist produces and employ that, implement that in production-ready environment? Okay, so that's another challenge. Because usually what happens is that once a data scientist is done, then you need to re-implement everything in a production-ready environment. Okay, to fit the scale, to fit the service consumption, let's say, model that you would like to have. Another challenge is, how do you sustain that? Over time, you will end up with multiple models that you want to test drive all the time. And then while situations change in your organization, right, those models might become invalid or lose their fitting to the situation in the enterprise. So how do you do predictive analytics with Behavior Workbench? What is this module that we're talking about? So first of all, Behavior Workbench is a new module that is exposed as part of the Behavior stack, an overlay layer that enables rapid development of analytic applications on top of behavior infrastructures, right? Vertical autonomy, Hadoop, and so on. While it is comprised of two main modules. One is the Haven Composer, and the other one is the Haven Advanced Insights. What I'm talking about here is the Advanced Insights part, okay? We call to democratize advanced analytics, to make it as simple as possible. So it will be engaging for business analysts, for developer, people who are not proficient in advanced analytics, machine learning, and all that. So, and we're providing it as an infrastructure that is hardly Haven stack. Okay, currently, it is currently showcased as a cloud service on the roadmap. We'll have to see what happens. And it is special in the sense that it is, first of all, very easy to use. It's very smart, because in order to bridge the gap between the data business analyst and the predictive model, right? You need to let go of the data scientist in the process. So you need to literally replace some of the best practices that the data scientist employs with smart stuff under the hood. Another thing is it is holistic in the sense that whatever you produce using that tool set can easily be taken to production. Okay? You don't need to re-implement everything in a production-ready manner. So, what are those best practices that a business analyst and data scientists need to start gathering together in order to create a predictive model? Well, one thing, data preparation. Okay, this is where a data scientist invests a lot of the time in preparing the data and massaging it and all that, because those machine learning algorithms that are dealt with are very specific. They know how to work on specific data types, okay? And some of them know how to work on graphs, some of them on matrices only, some of them on text, but you need to be very specific in regards to how you implement the data, how you transform it and prepare it for those algorithms. So this is another thing that consumes a lot of effort, right? Because the data that you have in your data sources is stored in different ways, right? You have files, you have tables, you have relational stores, you have all kinds of data sets in your organization. So one thing that we're doing in the process is we're automatically scanning the data as it is uploaded into the system, by deriving metadata out of it, and trying to realize what is informative in the data, what is not, what is highly correlated to the in the data. If you have, let's say, two columns in the data that both have the cost in more than one currency of the same product, then that would not be something that would help the model to understand something in regards to the context. Okay, so automatically realize that you have those, for example. Another thing is what analytic methods would be best fitting for your situation. Do you need to classify your data? Or do you need, for example, to project some behavior of the data onwards into the future? Okay, what's called regression models. Okay, so what would be the best analytic methods for your objective? Another thing, once you have realized what is the analytic method, okay, so then which algorithm would you use? When you're dealing with data science and all that, you have multiple algorithms. This is a whole area of skill set that you're required to master, right? And data scientists in most cases will deal with 1, 2, maximum 3 algorithms that they have experience with, that they've learned how to tune, and then they will start to fit the problem to the tool set. Okay, so this is something that we're doing inside the product. We're embedding algorithms that are fitting with those analytic methods that you would like to employ, and then we're working that in the process. Another thing is complex model training. Okay, so while training the models and all that, then you need to run some data validations. As I said, those algorithms are quite specific, okay, and they need to be quite tuned in really granular manner, okay, so they'll be able to operate properly on the data. So we're doing the parameter selection. That is what the data scientist would do, right? run the parameters, change them, see how it affects on the model, its accuracy, and so on and so forth. So you need to invest a lot of time and effort into that process, because each and every cycle that is done might take hours, okay? And that's manpower that is very expensive, manpower that is invested into this. So in a nutshell, you can regard to this process that happens as an optimization process, model optimization process, okay? So this is what I call the data science in the box, okay? We've wrapped all those best practices, we've coded it into the mechanism, okay? And then what we're doing is employing those methods within a process. So let's see how it is done using the Haven Workbench. Okay, so in a nutshell, what this module provides is the means to select the data. Once it is uploaded, let's say to HDFS, or you can upload it into that into the select data block over here. On the next stage, what it does, it enables you to select how you want to analyze the data. You simply select that you want to produce a predictive model. What the mechanism here does, it actually spins off processing power on Hadoop, for example, okay, in order to start learning your data. These are machine learning algorithms that automatically train on your data in order to realize how to classify it, how to create a predictive model. And then when it's done, when that process is over, what you get is a good indication of how accurate the models are. Then you can select it and go and publish it as a REST web services for consumption. Okay, then you can simply use a service in order to apply the model on data that is in HDFS, or consume it in a request-response manner. Let's say, for example, you would like to have a sales opportunity being predicted on whether it's going to be won or lost, okay, in the future. So you would want to develop a function on your CRM system that will consume that service and get an indication whether that opportunity is going to be won or lost. So if you want to see the showcase of it, so it's possible to see that in the Haven wall over here. We'll have a booth where we present the Haven Workbench. That's it. Thank you.